Okay, welcome to the video for 7A through 7C. So for 7A, I can draw geometric figures, and we're going to define some words while also seeing what they look like when you draw them. So our first word here is symmetric, and this is a figure that you can fold in half. So if I have an isosceles triangle where two sides are the same, I can fold it in half right here, as opposed to a scalene triangle where no sides are the same. There wouldn't be a line on which I could fold it on top of itself and it would cut right in half. Okay, our next word is line of symmetry, and that's just the line that contains the fold. So this is the line of symmetry. Okay, next word, line, is an infinite set of points that satisfy an equation, and the important thing to know is that it goes on forever. And the way we draw one is to draw, yes, a line, but you need to make sure that you have arrows at either end of your line. That's showing that it's going on forever. And then to name this line, we would have, well, you can name it a couple ways. Sometimes you'll see a cursive letter off to the side, so like this, and then we would call this line L. But more commonly, you'll have 2 points on the line, like A, B, and that would make this line AB. And the important thing to remember is that when you write this, you're going to draw a line with arrows on it to show that it's line AB. This is the notation to say, like if you see a problem or something that we're talking about line AB, we're talking about this line over here. And we're talking about the whole line as it extends forever. And that's important to understand the difference because we're now going to talk about, let's move these over here so we're not distracted, but line segment. So line segment is part of a line that contains 2 endpoints and all the points in between. So for instance, on our previous line, we could have a line segment on this line that's just called AB, and it would be the 2 endpoints and all the points in between. So this orange figure here would be a line segment as opposed to the black one being a line. So a line segment, and I'll just create another one over here with some different letters. We'll call this one QR. And the notation for this would be QR with a line segment above it and to not have arrows on there. That's how you write about this line here. Next, parallel lines are lines in the same plane that do not intersect. So as lines go on forever and ever, they would never intersect. Okay, and that could be hard to draw perfectly. So to show that these are definitely parallel lines, the way we show that in a picture is we draw these little kind of arrows on there. So one arrow each would mean that these are parallel to each other, or you might have another set of lines, the same picture, that are parallel to each other. And to show that they're parallel, I wouldn't, if they're on the same page or picture as these, I wouldn't just do 1 arrow each, but I would do 2 to show that they're parallel to each other. Okay, so those are lines in the same plane that do not intersect. Now we're going to look at perpendicular lines. And perpendicular lines are lines that intersect at a 90-degree angle. So if we have a couple of lines that are intersecting, we can't call them perpendicular until we draw this little box here. This little box is telling the viewer that these are perpendicular lines and that they're intersecting at 90 degrees. So it's not just intersecting, it has to be intersecting at 90 degrees. Okay, a plane is a surface with no thickness that extends forever. So we generally draw a plane kind of like a parallelogram, so it's like we're looking at this little piece of a plane from above. And the way to name a plane is you need 3 points on the plane, and the points can be within like this, or sometimes you'll see them on the edge. So this would be plane PQR. Okay, how about parallel planes? Well, parallel planes are planes that never intersect, just like parallel lines, and they're just going to be drawn like that, kind of floating above each other. Okay, next word, a prism. And a prism is a solid form, is a solid formed by translating a given base shape into the third dimension along a line. So let's see what that looks like. I'm just going to do a little sketch off here. But let's say if I have a square, transforming it would be to move it or to copy it along a line. So if I were to draw a line like this, and then I were to move and copy the same shape going back along this line, it would look something like this. So I've just taken the square and copied it going back. But that's not typically how we draw a prism. So we're going to go through the steps of how to actually draw a prism so that way we can sketch some of our own when we need to. So let's just take a shape, and we're going to take not a square, but something just a little more complicated. We'll do an L. Let's get some space down here. So I'm going to draw an L shape, so you do the same. Okay, and I want to make a prism out of this shape. And so typically when we look at a prism, we kind of see it like we're looking at it not directly flat on, but kind of at an angle. So the first thing we're going to do is rotate this L visually. And the way to do that is we're going to keep all these lines straight up and down, so vertical, but we're going to go ahead and change these horizontal lines and make them diagonal. So this part that I'm making right here, I'm going to do a little bit on the diagonal. And we'll bring that the vertical down. And then this one, which was going horizontally, is now going to go on a diagonal parallel with this line. Like that, straight up and down. Make these parallel. And then that one goes straight up and down again. Okay, so now we have our shape kind of rotated. And guys, this isn't a drawing class. You can see mine's not perfect. Yours doesn't have to be perfect either. We just want to be able to make a sketch. So we've taken the L, we've rotated it a little bit. And now we need to make a copy of it. So go ahead and draw yourself another one. I'm just going to copy mine like this. And set it away from the previous one. Something like that would be perfect. Okay, and now is a good time to talk about what a base is. So I'm going to bring that in. I'll put it kind of down here, but it goes with this. The base are the two identical and parallel faces that have been translated along the line. So up here it was the square, here it's going to be the L. And this is important because a lot of times in geometry, people always think that the base has to be at the bottom, but that's not true. It's the identical faces that are parallel to each other. So they've been translated along the line, and let's add on that are parallel to each other, because that's an important part of it. Okay. So here we go. Now our next step is to connect corresponding corners here. So I'm just going to take some straight lines and connect all my corresponding corners. As you can see, having all these extra lines can make it very hard to read. So what you do after you've done all this is go ahead and erase anything that's in the background. So this whole line that I just drew in, I didn't really need to draw in, but I can go back and erase it. This line in the front, I'm going to keep. These lines back here, I want to get rid of to make sure that I can see this shape clearly. Okay, so we've gotten rid of all of our hidden lines here that we don't need. And then the last thing we're going to do is we're going to shade them, shade the figures so it makes sense. And what I mean by it makes sense is you're going to have to shade parallel faces the same color or the same darkness. So for instance, if I go to shade this top part here, just a very light gray, that would mean that any other part that's parallel to this face would also have to be that same light gray. So right there, that's super duper light. I made it a little bit darker. All right, so now let's shade these two faces the same because they are parallel. Different colors, that's helpful. You can make it darker if that's all you have. I don't know how well this is going to show up in the video, but this is definitely a lighter gray on top, and this is more of a bluer gray on these two faces. And then I'm going to go with a darker blue on this side. And then I do not have a face that is parallel and showing with this, so that's all I'll shade there. And I'm actually going to make these darker so it stands out a little bit better. There we go. Okay, by shading these faces, we're giving our 3D figure some depth. And we can also tell what is parallel by the figure. And so we're practicing drawing this, not because I'm going to have you draw a ton of these, but if you understand how these are drawn, you'll be able to read them better when we use them for problems. Okay, so that's it for 7A. Now we're going to look at 7B. I can visualize mental images of geometric figures and analyze their cross-section. So one way to do this is to picture the shadows that a shape would cast. So here we have a question mark in the middle, and we're trying to figure out what shadow this shape would cast so that from the top we'd get a circle, and from the side we get a triangle. So pause the video and see if you can come up with a shape in your head of what that should look like. Okay, hopefully you've come up with something. So now let's see what it is. Well, if I had a solid cone and I shaded it from, or I threw a flashlight on it from the top, I'd end up with a circle on the bottom, and then from the side I'd end up with a triangle. Let's try that same exercise for this one. What could you come up with that would create a rectangle when shaded from the side or lit from the side, and a circle when lit from the top? And pause the video and see if you can come up with something for that. You hopefully came up with a cylinder. And notice that these are drawn in 3 dimensions. Instead of totally erasing the back, you'll also see them sometimes drawn with just little dotted lines back there. All right, so I'm going to leave this last one for you to try to figure out. See if you can sketch something that would create this interesting shading pattern depending on what side it's being lit from. Okay, so all of this is leading to explaining what a cross-section is. And a cross-section is a shape we get when cutting through an object. So the basic ones that we're going to be looking at can be also thought of as shading from a side. So here we see the cylinder again, and instead of shading, it's been cut out in the middle here where you get a circle. Or it's been cut out vertically here and we get a rectangle. But keep in mind, even though we're not going to get into cross-sections this complicated, cross-sections don't always have to happen in such a manner that you would get a shade that's the same shape as the cross-section. Sometimes they can be at different angles, they can be anywhere inside the solid. But this is what a cross-section is. Okay, our last objective here is I can write and follow careful directions using specific vocabulary. Okay, so here we have some directions from the book, and they sometimes call it a recipe. I'm just going to lead you through a couple of these steps so far are in the video, and then I'm going to have you finish it up on your own. All right, draw a horizontal line segment. So in the space down here, I'm going to go ahead and draw a horizontal line segment. So I do not need arrows on the end, but just like that as a horizontal line segment. Then it says above the segment, draw 2 circles that are the same size and tangent to the segment. And then it's giving us some important information here. But tangent means just touching. Leave some space between the 2 circles, a space roughly the size of the circle's diameter. So let's go ahead and give that a try down here. You're going to have to freehand it, but I actually have some tools that I can use here. I'm going to draw 1 circle, make it a little bit bigger, and then I'm just going to copy that circle so it's the same size, and I'm going to give about that space in the middle, just like that. And these are just touching in that the circle just has 1 point that it intersects with the line. All right, draw a line segment above the 2 circles and tangent to them. It should extend slightly beyond the 2 circles. Label this segment's left point L and its right point R. Okay, so coming back down here, just reread it if it doesn't make sense, but all we need to do here is draw a line segment that's just touching and going a little bit past the circle. So I'm going to make it a little bit bigger on the left-hand side there. And then I need to label it so the left endpoint is L and the right endpoint is R. Okay, that's all I'm going to do for you. I'm going to have you finish it up, and then when I'm checking your homework in class, I'll be able to tell by the image that you created whether you were able to follow those directions carefully. But just go back, make sure you read what it says, and just take it step by step and take your time with it, and you should come up with the right image. Okay, that is it. If you have any questions, write them down here so that way we can talk about them in class.